Have you ever wondered how your item gets from country A to country B that can be from the other side of the world? Seaports. Yes, seaports. Seaports, by definition from the Britannica dictionary, is a town or city with a harbour where ships stops to load and unload cargo. One major example of this in Malaysia is Port Klang, and of course there are others such as the Port of Singapore and the Port of Shenzhen in China. So, you might be wondering why ports are so important. There are a few reasons why they are so important. In general, ports are the places where cargo docks, and in those cargo containers, they contain goods which include food, oil, or even cars. All the ports usually have important connections and integrations with some of the vital infrastructure within the country, such as railway lines and common truck shipping lines, which carry the cargo things from the ports into the country. They keep the business moving and your stuff moving around the world. Without the ports, international trade will literally come to a screeching halt, where no items will be traded across countries or even within countries. They are so vital today where even one small disruption to the lines will cause massive problems that will resonate throughout the world economy. Remember the traffic jam on the Suez Canal? Yeah, that thing. Over USD 9.6 billion of trade was lost. Imagine if one of the ports suddenly broke down. Whether it's due to COVID or some governmental procedure or anything, it will definitely cause a lot of productivity and money to be lost. The ports we have right now are nice. They are always bustling with cargo, it's always busy and always filled with daily operations. But they can be even better. Let's implement more advanced technology that can speed up in the day-to-day operations and turn those regular seaports into smart ports. What's a smart port, you might ask? It is an automated port that runs on smart technology to have an increase in efficiency, improved performance, and economic competitiveness. The improvements can be anything from digitalizing shipping processes, leveraging the use of 5G to more efficient communications between other ports and cargo ships. Basically, smart ports are the more efficient, effective, and ever more productive of regular seaports. Let's talk about 5G. 5G is the latest generation to the game, and the main selling point of this generation is its speed and low latency, where both of these enhanced properties can greatly help in day-to-day operations. These advancements are so impressive that it can affect all communities, and the effects can be seen in the real world.
For starters, 5G enables massive machine-to-machine communications. The Internet of Things, or IoT, where millions of devices on the internet are connected to each other. IoT devices can range from small sensors all the way to heavy machinery. They communicate with each other and work together to accomplish a task much more quicker and safer. Like a crane lifting a heavy container, for example, the small sensors that are placed on the load can assist the situation by providing more context to the crane operator. This helps the crane operator, who might be a person, to operate much more efficiently with the information given. This ultimately results in a safer environment for everyone that is involved in the process.
Next, let's talk about the low latency that 5G provides. Since the bandwidth that is available is so wide, multiple access mechanisms are much simpler, up until the point where one device might have entire subband that is allocated to it. Think of it like a highway, but the 5G highway has so many lanes that congestions would never happen. This in turn reduces the total waiting time and processing time, which then in turn reduces the latency that it takes to communicate between the devices. With this low latency in place, mission-critical tasks that rely on low latency input from all sources are now possible. This opens to many possibilities, such as real-time control of a port crane from a remote location, or simply remove the human aspect and letting AI handle the task autonomously.
Last of the highlights is the enhanced mobile broadband. With this amount of bandwidth that is at our disposal, downloading a file might be a thing of the past. That 4K Blu-ray CD, you can just stream it off the network, no downloads required. It might be even possible to replace your home fiber internet with the amount of bandwidth it has. This translates into huge cost savings, both in reducing costs spent on operating server farms and infrastructure. 5G has so many advantages, but we can do better.
5G still has some issues where it can't be fully implemented in ports, something as simple as the protocols, which still can be improved. since every single network design out there is based on the OSI model. For the uninitiated, the OSI model is a very theoretical model that serves as a guideline for designing a network. There are other architecture, but let's just ignore them for now. The OSI model was introduced quite some time ago, specifically in 1983. 5G, being a network standard, still follow this model. Our team wants to highlight a few changes that can be implemented to make the current 5G a more suitable version to be implemented for smart pods. The layers that we will be talking about specifically are layers 4, 3 and 1, which are the transport, network and physical layer.
Firstly, the network layer. It's the third layer in the OSI model that organizes and transmits data between multiple networks. Its main responsibility is routing data through the best path based on a range of factors: network characteristics, best available path, traffic controls, congestion of data packets, and priority of service. Hardware devices like routers, layer 3 switches, and protocols such as Internet Protocol version 4 and Internet Protocol version 6 belongs to the network layer. Not only that, routing protocols such as Routing Information Protocol and Open Shortest Path First also plays a role in this layer. These protocols specify how routers communicate with each other to distribute information and select routes between nodes. With the current state of how the network layer works, there are several vulnerabilities that can affect the performance. Some of these vulnerabilities are cybersecurity attacks, and one of these attacks is IP spoofing. Essentially, hackers basically use tools to modify the source address in the packet header to either hide the identity of the sender or to impersonate another computer. So, this allows the attackers to carry out malicious actions without detection. Another example of the attacks is a man-in-the-middle attack. This attack is a general term for when an attacker positions themselves in a conversation between a user and an application to eavesdrop and intercept the message. So basically, it's like a man standing in the middle of a conversation and he doesn't contribute anything to it, and he just listens. Anyhow, the OSI model is not something that was made recently. The researchers in the cybersecurity field have found ways to mitigate these security issues. However, it does not eliminate them completely. To reach this goal, let's dive into the future and see how we can help secure the internet. One improvement we could make to the network layers is implementing public key infrastructure, or PKI, natively. Most organizations use PKI to manage their security through encryption. In PKI, there is a public key and a private key, which can be used to encrypt and decrypt a message. PKI is mainly used in the application layer because data security in banking apps, secure messaging apps, and encrypted XML documents is very important. This, however, is not present in the network layer unless an organization configures their system to implement PKI. Using PKI to encrypt our IP addresses make it more difficult for hackers to perform IP spoofing and man-in-the-middle attack. This is because they will need to determine the private key first, which is not publicly available.
Now onto the transport layer. The transport layer plays the role of transporting messages from one end to another end, just like its name suggests. This layer has been referred to as the heart of the OSI model because it is used for computer-to-computer communication. It takes messages from the upper layers of the OSI model and processes it so that the lower layer can process the data received. The transport layer is mainly responsible for performing a process called segmentation. Basically, when data is to be transmitted, the transport layer breaks the data received from the upper layer down into segments that can be processed by the lower layer. In the other way around, broken segments from the lower layer will be reassembled to transmit to the upper layer. This layer also performs error checking for both transmit and receive operation. As 5G network is adopted, software-defined networking, in short SDN, will be one of the enabling technology for the transport layer, as SDN will make the most out of 5G network. However, there are still vulnerabilities in the current transport layer from the perspective of SDN. As SDN is centrally controlled, it is susceptible to any kind of DDoS attack, specifically the two types of attacks that are common to the OSI transport layer, which are seam-floods and smooth attack. A seam-floods attack happens when an attacker initiates a large number of connections to a server using a spoof IP address while not waiting for a connection to finalize. Smooth attack, in another way, uses malware to overload the network resources. Both of these attacks aim to reduce the victim computer network inoperable. So why is it that this attack could happen in this layer? It's mainly due to weak authentication for the application and user, thus creating a weakness for the attacker to exploit. Apart from that, before routing information is created for packet routing, a proper authorization is required for accountability purposes, but the current implementation has a lack of encryption standards during application or user requesting a service from the 5G network, provide a chance for the attacker to attack. The solution to these problems could be solved quite easily. The security should be pre-built into the SDN architecture. For example, SDN could use an architecture with two communication channels, such as the control and data channels. The control channels transport only the control data between the control and data planes. On the other hand, the user communication data is transported only through the data channel. Besides that, we also can design components to secure the SDN controller, protect the flow layer of the SDN, and harden the interface such as the core APIs. As SDN is implemented, rapid deployment of security policies can also be achieved where traditional security approaches may not be easily possible.
Lastly, the physical layer, also known as the first layer of the OSI model, is the electrical and physical representation of the network layer. It consists of various network components such as power plugs, connectors, receivers, cable types, and many more. The physical layer sends data bits from one device to another device. This layer defines the type of encoding on how the zeros and ones are encoded in a signal. The major functions and services are performed by the physical layer are the establishment and termination of a connection to a communications medium, participation in the process whereby the communication resources are effectively shared among multiple users, modulation or conversion between the representation of digital data in user equipment and the corresponding signals transmitted over communications channel. For 5G wireless signal transmission, which is transmitted in free space, attackers can obtain private information from oscillations in the observed power. This allows eavesdroppers to obtain the ciphertext, since anyone can listen to it. However, if a large number of ciphertext is captured, it is easier to infer the security scheme applied at the upper OSI layers and private information can be stolen. This can be solved with a technique called beamforming. Beamforming is a type of radio frequency management in which a wireless signal is directed towards a specific receiving device. Essentially, a beamformer controls the phase and amplitude of the signal at the transmitter in order to create a constructive and destructive point. This can deliver a better and a higher signal quality to the receiver. Beamforming is a useful method to avoid leakage of transmission power, which in return reduce the possible eavesdropping events that occurs on the physical layer. Usually, this operation is jointly performed with the power control section, which will lead to increase of the transmission speed while reducing the transmission power due to non-directed beams.
With the improvements to the say OSI layers mentioned, the overall change relates to increasing security and privacy. The network layer will provide enhanced authentication methods for IoT devices used in smart pods to communicate with no more spoofers, and if anyone tries to carry out an attack to intercept or impersonate one of the parties to send false message, the network layer's PKI authentication should be able to prevent it. The implementation of software-defined networking (SDN) in the transport layer built along with an architecture that allows the use of multiple channels, one channel being used for control message and the rest for data message, makes communications between smart pods more secure. This allows the separations of important server message and user message to reduce the chances for smart pod network to crash in the event of any DDoS attack. Beamforming used in physical layer avoids the leakage of transmission power, which could reduce the opportunity for eavesdropping, while being able to increase the transmission speeds and reduce power that is wasted due to non-directed beams. Communications between smart pods will have lower latency and higher security this way. To further give a clearer idea of how these improvements take effect, let us look at an example of a typical operation being carried out in a smart pod. An operator is in a control room that is not on the crane, operating the crane to unload the cargo. With enhanced authentication and SDN implemented, no one should be able to intercept and take control of the CRAN or be able to render the system inoperable and lose control of the CRAN. Beamforming will allow the operator to connect from a distance so they do not need to risk themselves operating high up on the CRANs and reduce the chance of information leakage regarding the movements of the CRAN. Once the CRAN is done unloading all the cargo ship can leave, and the system can be used to update all the other smart ports in the real time regarding the vacant docking spaces of the current port. This allows quicker notification to other smart ports, which leads to the area response times.
In conclusion, there are improvements that can be made to the OSI layers and help in accelerating the implementation of smart ports. We strongly believe that with the changes that I mentioned, it will help not only the smart ports alone, but it will also benefit everyone as it can be implemented anywhere. With that being said, thank you for watching the video and do comment below about what do you think about 5G and the changes that should be made. Stay safe and have fun.